Hello, it's Duncan. I'm going to fast follow my last video on Kotlin Power-Assert with another on the same subject, because I'm excited about the technology and the author Brian Norman has been very helpful on the Kotlin Slack. So, without further ado, let's hack on Kotlin Power-Assert a bit more.
That's interesting. Brian Norman from JetBrains, who wrote Kotlin Power-Assert, was good enough to give me some feedback on the last episode. And one of the key things he pointed out is that we can enhance not only assert, the one that's assert Boolean, but also assert equals. And in particular, that gives us a bit of diff. So at the moment here, if we were to use unexpected price stock list in our assert and run this, then it would fail as we expect, showing, well, if we trace down far enough here that this equals was false, but without a nice diff. We can fix that though. If we look in the build, we can put back the configuration for Power-Assert, and we can use Kotlin test assert equals in here. Now if we do that, and in here then say assert equals, and we'd normally say expected and actual, so I guess that's that way around, and now run this and return to the top. Now then, this rendering isn't great, and it looks like this wants to line up with this, so this error message here isn't really being expected by the renderer. I wonder if we can fix that just by putting in a blank string. For now, try that. Back up to the top. And yes, we are now laying out better. And we're seeing the expected rendering for the price stock list and so on. But if we scroll down here, here we go. We do see our click to the difference. And now IntelliJ shows us the nice diff. I assume from parsing the actual and expected from inside here, but I don't know, to be honest. And so again, I suppose we should probably use assert equals in there, and that would allow us to say comma status, but we tediously have to add in an empty string for some reason. And then if we return this to expected price stock list, then things should be good. And I'm just going to pull this assert on its own out of here, because I want to look at the multi-line behavior. So let's just make that like that. Body string is response.bodyString. And now if we make this unexpected price stock list and run this, and let's have a look at what we have. Brian accepts that rendering of multi-line things really isn't working well. I think what we're seeing here is that the response here, body string, which is the thing furthest to the right and so is rendered first, actually starts with a blank line. So what we're seeing here is a blank line followed by the rest of the response's body string justified to the left. Now I think that all of this should be indented as far as here, but a problem is that we're already using a pipe character that we might otherwise use to show the indent. I have some ideas for what might be able to work. If we chase these down, so this here is the initial body string, after which here this is the body. So that starts with the HTTP OK, here are the headers, but again left aligned. So with multi-line strings, everything is pretty confusing, although to be fair, the same is true of strict, really. Because the multi-line strings make it so hard to see what's going on, and because we're just experimenting, I think what I'm going to do is I'm going to take that out of there, so that everything passes. Good. And I'm just going to write a separate test for our next experiment. So as it's very much just an experiment, I'm just going to put in here a class Power-Assert tests, and with a test. Okay then, so instead of HTTP for K's responses, let's just set ourselves up with a little data class. We'll say data class, test data, and val power double, well, I don't know, val a string, which is string, and val and int, which is an int. So let's see the behavior with that. We'll say val expected is test data banana and 101. And let's say that our actual was banana and 102. So let's see what happens if we say assert equals expected actual, and we'll run just this test. But now we have again this issue with the indent. I wonder whether we just write our own assert. So in here we'll say fun assert. Well, let's call it Power-Assert equals, shall we? Then we'll know what we're dealing with. And as with the Kotlin one, that's going to be a fun of some sort of t. It's going to take an expected t and an actual t, and let's say a message, which is a string, which is initially null. And this is going to just call the Kotlin.test assert equals, like that. And now what we'll do is we'll change it to not enhance the Kotlin version, but enhance ours. So this is com.gilded_rows Power-Assert equals. Okay, back here then. Let's use that in here. See that it is working. And we still had the indent problem, so let's see whether we can solve that by making this explicitly an empty string in here. And run. And no, we can't. That's annoying. Well, until that's fixed, let's just put it in here explicitly. So we'll force ourselves to give a message. Does that work? Yes, it does, because it moves that up a line so that these now all line up properly. That's good. And now to simulate the case where I want to test just some of the data, I'm going to add in another property here. So we'll say val bstring will do. So banana kumquat. And now instead of Power-Assert equals here, we're going to use our assert all here, the one that uses JUnit assert all. So what we're going to say in here is assert all. Now the subject is going to be actual. And now we give a set of lambdas, which are checks that take the subject, this thing here, as their receiver. So this can say Power-Assert equals, and we want to say that banana is the actuals.aString. We could say actual.aString. We need to pass a value for message, but because this has the receiver of t, we can leave that out and just say a string. And we want to test the other thing, which is that, let's say 101 is an int. Don't know what went wrong there. We seem to have lost the subject. Ah, no, we need a comma. We'll fix that in a minute. So now we don't need an expected. We've got an actual, and we're making assertions against that actual for two of the parameters. So we don't care what the B string is, but we do care about a string and an int. So this should fail because that's 102 and that's 101. Let's have a look. And it does. And you can see here, we've failed Power-Assert equals. An int was 102. And this annoying little thing here, this here seems to be the receiver that we're not seeing for an int. So it is in fact our actual, and we're seeing it there. This little bit here is put in there by JUnit when an assertion fails. That means we can click to see the difference. That's good. And down here we've got our multiple failures error showing that we have one failure. And if we made two failures, so we had misspelt banana, let's say, then we do the first failure here, that a string is banana, and the receiver that we can't see is the test data. In fact, I suppose if we put this in there, that would be better. Let's have a look. Ah, that's quite a bit clearer, isn't it? So you can see we now have one failure for banana. Expected banana was banana. Interestingly, this literal here isn't being evaluated. It's just left in place. I suppose that's sane. So that's one failure. And here's the other failure. This an int should have been 101 and was 102. Interestingly, I've messed that Power-Assert equals up because the types are different. I wonder why I was able to use string here and int there. That's interesting. Don't understand it, but not the swamp I'm trying to drain. So let's go back down here and you can see we now have a multiple failures exception showing both of our errors at once. What we'd like though is if we only have one of these failures, that we saw the other one not as a failure but showing the values. That's what strict does. Let's just do the strict version. So this is test Power-Assert. And let's do the same thing in the strict way. So we'll say test strict. And let's see what strict does. There we go. Strict gives us a failure. But at the end in the summary here, it says, look, here's a string, and you wanted it to be equal to banan, but it was actually banana. And an int, you wanted to be equal to 102, and it was. It would be nice to do that sort of thing with Power-Assert, and it turns out we can kind of get there. The secret to this is that Power-Assert doesn't really need to be run on a assert function. We could run it on something like fun. I'm going to call it describe, that takes a subject, which is any. And providing we have a last parameter that's a string, then Power-Assert can enhance it. So in here, we could actually say that I want to just have this return the message. That's a bit weird, isn't it? But let's have a look and see what happens. We will write in here a test describe. And here I'm going to say describe with our subject. Well, let's put in some value for test data. But I'm going to take this and put it up here so we can share it, I think. So we'll get rid of that one and that one. So we're doing the same thing every time. And that's it, describe actual. Now, we need to call this one here with a message. So let's do that with double quotes. And then we're going to print them the thing that comes out from it. And we're going to tell Power-Assert to enhance that. And let's see what happens when we run just this test. And there we have it. Power-Assert has enhanced the message, which went in as an empty string, to show you the value of actual. And as it turns out that actual is now a field of the test, we're seeing the field here. So again, it might be clearer, I think, to put this dot actual in there, and then we could see it like that. So how can we use that to get strict-like output? Well, first of all, I want to fix this irritating commas in here. It would be a lot nicer if this was DSL-like, and what I'd like is something like this. So we'd have a block in here where we could say Power-Assert equals a thing, and then Power-Assert equals another thing. Oh, and then that block would finish with a curly. Now, in order to make this DSL work, we'd need a receiver. And that receiver will mean that we can't use this as the receiver. So what I'm going to do is I'm going to change that from this to it. So there will be a parameter to this block, which is this actual. Very much like a let from that end. Okay, let's fold that away so we can see what we're doing. And so now assert all is going to do something different. It's going to take a block in here. And the block's receiver is going to be the place that we have Power-Assert equals. And the block's parameter is going to be the subject. So that's going to be the T, and this is going to be, let's call it assertion context. We don't have one of those yet. Okay, what's an assertion context? It's a class, and assertion context is the thing that's going to have Power-Assert equals. So we're going to move this into there. Now, if we allow Power-Assert equals to just run assert equals here, this one will run, but an exception will be thrown and this one won't. So what we're going to do is we're going to try to run test assert equals, and if we get any exceptions, and I think probably we're going to have to be throwable because assertion errors are, then we are going to remember that throwable. How are we going to do that? Well, I think we're going to say we've got a val thrown is a mutable list of throwable. And when we've got one of those, we can say thrown plus equals x. All right. So now each one of these Power-Assert equals will be run straight away, but we're catching any failures. So in here now, what we're going to do is we're going to say we've got the context is a new assertion context. Now we're going to run the block, giving the assertion context. So we say context dot block, and remember the block here has the subject as it. So we're going to put the subject in there, And now let's look at what assert all does. It says assert all, assertions assert all, which does assert all. Goodness me, does a bunch of things, but here it throws multiple failure errors with a heading and failures. Aha, so we can do that ourselves. So in here we can say that if context thrown is not empty, throw the multiple failures with this as our message and context dot thrown as the errors. Well, it compiles. Let's try it out. So if this is banana, we expect it to run. Oh, we have changed the interface, haven't we? So let's just fix this up in the same way. So we'll say this is response. It takes that, and then these are both Power-Assert equals. We don't need the lambda on the end, but we do need to qualify this with it, which is our response. There and there. That compile now. It would if I made that a brace. Good. Okay, looking at our test, I still messed it up because this should be 102. Run that. And it passes. Good. Change this to banan. So we're seeing the assertion failure error. But that's not instrumented. Let's work out why. I guess because we moved it. So the assertion context now has Power-Assert equals. So let's take that and say, hey, it's this one we want, which is com gilded rose assertion context Power-Assert equals. Let's try that. Good, we've now got our expressions debugged. Now, to see the expressions that passed as well, we can use what we found in describe, which is that this message is filled in whether or not the assert happens. So we can add ourselves in here a val messages as a mutable list of string. And if we get to here, then we can add to messages with knowing it's a pass, and we can put in the message. If we get to here, then we know it's a fail. And now up here, we can use that to build a long description here. So we can say for subject and then add in the context messages join to string with a new line. And if we run that, then here we see the assertion failed error where we can click see the difference. That's for the one failure. And then down here we see the message, multiple failures error for test data. We failed with Power-Assert equals banan with the debug here, and we passed for 102 is our int. And here, this is the message from the failing test, repeated for some reason from up there. So a little tiny bit more work. It looks like the message has a new line in it already, so we might take that like that, and that like that. Try that. Now we have fail and pass. That's weird. Oh, idiot. I need to make that a dollar. There we go. So there's our failure. That's a bit that passed, and our failure again for good measure. I think if we worked hard, we could even take this expected banan but was such and such and move it up into the failure reason here. But I suspect this episode has been long enough already. Notwithstanding the fact that we've both been here too long, there is one more trick we can play with Power-Assert that I think is worth noting. I've created a Power-Assert test here so we can concentrate on what we're doing. And the thing I want to show is what happens if test data could be null. So if we want to assert against something that might be null, we could say this could be test data ? And now you see both forms of our test, the Power-Assert and the strict ones, can't compile, and both for the same reason, because in both cases we'll be taking something here and trying to call a string on it and an int on it, but we haven't checked it for null. Now strict has a trick up its sleeve. We can say dot is not null, still doesn't work, but then we can say and that checks to see whether it's not null, and then makes the receiver of these things into a not nullable thing. So if it was null, we'd get a failure message saying that it was null, and it wouldn't check these other things. Now that's kind of like Kotlin flow typing, where previous statements can affect the type of an expression, but it's actually a previous part of this expression. Putting this into this expression means that we've changed the type here. Now it turns out that plain old Kotlin assert true, said in here assert true, actual, I'm pretty sure I didn't want that, is not equal to null, and import the Kotlin test version. That interacts with flow typing. You can see here it's saying, look, actual has been smartcast. It knows that it can't be null if it got through this statement. And so if actual can't be null, then it can't be null. That's really handy sometimes in tests. And in fact, we'd like probably to be able to say that in here, we'd like to be able to say something like Power-Assert true using the it. Now we don't have one of those, but let's create one. You can see that I've extracted some of the workings of this, which means that we should just be able to write fun Power-Assert true, and that will say run with message assert true from Kotlin test. I don't think that would be quite enough, and indeed it isn't. But if we go and look at what assert true does, it has this contract. And the contract says that if this returns, it implies that actual is true. So we can take that, make this into a block body, put that into the block body. It turns out we have to jump through a hoop for contracts because after 4 years they're still experimental. But I think we can do that for all of assertion context. And now if we go back up here and opt in up here and pass the message to get over the bug in Power-Assert, now we can have flow typing inside our assert. Of course, in order to get Power-Assert functionality, we need to add that to our list in Power-Assert here. And unfortunately, .star doesn't work, or everything from a context. So this would get unyieldy pretty quickly, but I think it's an interesting proof of concept. And certainly interacting with flow typing is a nice feature of an assertion library. Oh, future Duncan here. I've just tried actually running this with test data as null. And what happens is that we get a null pointer exception here. I guess because in fact our Power-Assert true is lying when it says it returns implies actual, because Power-Assert true has returned because we're catching the exception here. I should have thought that soft assertions are fundamentally incompatible with contracts, so whilst this was interesting, I don't think we should be saying that at all here. So I suppose what we have to do is go back up to here and say this is just going to be our assert true. That can now be actual, and now our flow typing works as we had it before. With a single failure. And if I Kotlin test assert true to the Power-Assert functions, then we can see the debug here from here, but now none of these statements are run afterwards. That's a shame, but it feels like it's just one of the laws of software physics. If you have a better idea, then please let me know in the comments. Now back to present Duncan. And finally, so you don't have to, I worked out why it is that this compiles when plain old assert equals wouldn't. And the answer is, if we look in assert equals, we have this input only types, which is an annotation on our type parameter that stops it being matched by any. You might think that we could do that for our Power-Assert equals. So we'd add that annotation in there. But unfortunately, input only types is internal. There are ways to make it available, but we're piling complication on top of complication. There is, of course, a keep for making this not internal. Maybe now we finally release Kotlin 2, the language team will be able to get onto some of those things. I hope you enjoyed this second dive into Power-Assert. It's nice that we can write all these things, but should we be giving up whatever assertion library we're using at the moment? Well, for all this cleverness, I think it's probably too early. Power-Assert has bugs, some of which are pretty fatal, and formatting issues, but it does show a great deal of promise. I think I'll be sticking to strict for now, but it should be noted that Rob Fletcher is no longer actively supporting strict, so unless someone else takes it on, sooner or later it will fall into disrepair. Other assertion libraries are available, of course. I hear a lot of good things about code test assertions, and there are others such as Atrium. Next week, I think we'll get back to comparing HTTP for K and Ktor, this time specifically looking at performance. If you'd like to see that, then please subscribe to the channel. Click the like button because that increases the counter somewhere on YouTube, and I look at the counter and it makes me happy. And if you've read the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, you could do us a huge favor and leave us a review on Amazon or Goodreads so that other people can find the book and buy it. Thanks for watching.